Okay, this section will be on just the carbohydrates here. So first of all, we use the term saccharide to describe a sugar. So for example, we could have a mono, a di, or a poly. So monosaccharide, disaccharide, polysaccharide, all of those mean different numbers of sugars. So sugars are sort of classified most simply as having ring structures. So for example, you would see like a 6-membered ring like this, and this could be glucose. You could have a 5-membered ring, and that could be fructose. There's other ones like sucrose, which have 2 rings on them, like so. Sucrose, sorry about the spelling here. Sucrose. So this would be a di, because there's 1 ring here and 1 ring here. This each would be a mono. And then we could use multiple glucoses. That's the most common one, where this connects to another glucose, connects to another glucose, connects to another glucose. So we have a long chain here. I only put 4 in this chain, but 4 or more, really it's 3 or more. And that would be a polysaccharide. So these are simple sugars. And polysaccharides are generally considered the complex carbohydrates. So which of these have more energy? Well, it kind of depends on their weight, really. So the number of rings that they have, this has 4 glucose molecules. So that's going to be about the same weight as if you ate 4 of these glucose molecules. It's really about the same. So it's kind of dependent on weight of the actual carbohydrate that you're eating. So let's talk about a few of these of mono or disaccharides. The most common one that we will see, I'm going to simplify this drawing a little bit so I can draw a little faster. So I'm just going to draw a hexagon ring like so, and like so, and like so. So this could be what we call a starch. And starches are made up of glucose. These are found in a lot of plants, and these are edible. So we definitely digest starch. Another one that's found in plants, but what ends up happening is these glucose molecules sort of tend to be inverted from one another. So the bonding happens at a weird angle, and then it's going to be a weird angle back up here. So what ends up happening is if this is one tip of the glucose, this is the same one, this is the same one for starch. What happens in cellulose is they get inverted from each other. And so the pattern is repeating, but it's opposite. So cellulose, this is also made of glucose, but I'm going to put the word inverted because it inverts each time. This is also found in plants, and this is non-digestible. So these are like your fibers and things of that nature. If you've ever seen like your pets eat grass, they're eating a lot of cellulose and they end up actually throwing it up because they can't digest it either. Some animals can. We certainly cannot do that either. So that's starch. Glycogen is pretty similar to starch, actually, except I'm going to erase this again. So what ends up happening with a starch will be like a long chain like this, made of glucose. Glycogen is a storage, sort of a short-term storage for glucose. And it stores it on a long chain, but there's all these branches that come off of it. And so it kind of allows it to like store more because of that structure. But you would have to imagine like all along here are these rings that I've drawn, like I've drawn up here. So these are all rings, like a long chain that branches off. So all these rings are connected along this way. Starch is the same structure, basically, except it is just one long chain. The last one, and we were to go back to this slide here, starch is pretty soft. Glycogen is pretty soft. Cellulose is much more rigid, sort of like chitin is, and it part of it is because of that inverted chemical bonding that happens between them as well. So I think we'll leave it there at that. Just understand that the different types of polysaccharides, and then a few of the time on this one for sure is chitin. This one is found in insects. I believe this one's non-digestible as well. And this is like the hard shell or exoskeleton of those insects. So this is kind of it's a different type of polymer because it's a glucose, but it's a special kind of glucose that has one group on it that's unique. So it has the same general shape, but it's got that one unique one. And it actually inverts as well. So this is most similar to cellulose. So we'll have an inverted look at this. But then there will be a special group sticking off of each of these. And so this special group is what makes this chitin polysaccharide unique, provides that really sort of hard shell that we don't see in some of the other ones. So